Welcome to the Pavilion HyperParallel Storage Array performance as it relates to SQL Server and Windows performance profiles, part of the Pavilion video series. I am Kostas Apopoulos, the Chief Field Technology Officer for Pavilion Data. I'll be joined with Phil Aronowitz, one of our Senior Principal Solutions Architects, who will actually give some demonstration. In this video, we're going to give you a brief overview of the Pavilion HyperParallel Storage Array and our architecture. We're going to give you a little bit about our test suite and our testing methodology, and then we're going to share our actual performance numbers by block size, by storage protocol, as well as by different operating system types. We're then going to give you a brief demonstration of actually running one of those performance tests leveraging disk speed. Before we move on, let's give you a brief overview of Pavilion's HyperParallel Storage Array and our very scalable architecture. The picture on the left is our rear view. The picture on the right is a top view. We are a multi-controller storage array. We can deliver up to 20 independent storage controllers, up to 72 NVMe U.2 drives today, delivering almost 2 petabytes of usable capacity. We can have up to 40 100 gig Ethernet or InfiniBand ports, all this connected together by a 6.1 terabit PCIe switch, giving any-to-any connectivity to every storage controller and drive into port. All this packed into 4 rack units. The result of this, leveraging the Pavilion HyperParallel operating system, we can deliver over 120 gigabytes a second read and 90 gigabytes a second write performance. Up to 20 million read IOPS and 5 million write IOPS. And latency as low as 25 microseconds in the write to 100 microseconds on the read. Delivering unrivaled performance density by leveraging the Pavilion HyperParallel Storage Array hardware mirrored with the Pavilion HyperOS operating system, delivering block, file, or object all on the same platform. In this video, we're going to demonstrate and show you our performance numbers for a single host performance with a single NIC. The focus on this is to demonstrate the very high performance Windows performance we can get and profile the IOs as it relates to SQL Server. We're also going to share some Linux numbers just for comparison. So the hardware configuration is a Pavilion storage array connected to a 100 gig Ethernet switch. Each one of the hosts has a single 100 gig Ethernet NIC in them, all with 100 gig connection. We're going to show you performance numbers using a Windows bare metal machine. We're going to show those using the protocol of NVMe-over-Fabrics RoCE, as well as the performance numbers using NVMe-over-Fabrics TCP. We're going to then show you the performance of a VMware environment, but Windows inside of a VMware environment. And VMware is VMware 7, leveraging NVMe-over-Fabrics RoCE to Pavilion. Just from a data point perspective, we're going to also share a bare metal Linux environments using NVMe-over-Fabrics RoCE and NVMe-over-Fabrics TCP. The tools that we'll use to show this performance in the Windows environment is disk speed and FIO in Linux. And remember, this is not a test to show the overall performance of the storage array. It's to show the performance of what a single host can get, really in the context and the spirit of what can a SQL server do. Right? So this is a test of a single host, single NIC. You will see it performance for each one of the block sizes. And then you will notice, and we can communicate to you, that every time you add a volume controller pair to a host or to another host, the performance linearly scales. So before we actually get into the performance numbers, remember this is a single host, single NIC performance characteristic, and the idea is to simulate a SQL server running on a host or any application of what an application can get from a storage perspective on a single host. Remember, single host performance is based upon CPU, memory, and NIC, and all saturation and wherever the bottleneck happens to be. And in our world, we're going to talk about a NIC, and a 100 gig NIC can deliver 12.5 gigabytes per second storage. As you know, storage is typically measured in gigabytes per second. And the concept here is for each block size can deliver X amount of gigabytes per second. If you need more performance at that block size, you can add more controllers or volumes or controller volume pairs to that particular host, and the performance linearly scales in the Pavilion environment. How many you need? Depends on the block size, depends on your hosts. You can also add more NICs to this and more volumes and controller pairs to get more storage if your system can support more data throughput. So with that, let's get right in and show you the performance numbers. The first set of numbers we're going to show is latency. Latency is the #1 most important storage performance metric as it relates to SQL Server, whether that's for transaction commit in general or transaction commit for HA. The reality is latency is a key factor in any database or really any transactional-based application. In testing latency, you test with a single thread count with a single queue depth to define the optimal potential latency that can be achieved through the ecosystem. In the table below, we've tested the latency for various block sizes. The rows are the block sizes, 4, 8, 16, all the way up to 1024. The columns are various scenarios in which we tested that block size. All numbers are represented in milliseconds. The first column is Windows TCP. It's a server running NVMe-over-Fabric with the NVMe-over-Fabric TCP driver. The second one is a bare metal server running the Windows NVMe-over-Fabric RoCE driver. The next one is a server running VMware, leveraging NVMe-over-Fabric RoCE, running Windows inside a VM. The next column is a Linux system running NVMe-over-Fabric RoCE. Linux system running NVMe-over-Fabric TCP is the next column. The first 5 columns are 100% read. The next columns are 100% write. We've highlighted the 64K block size as it is the key block size for measurement of SQL Server. And you will see in those performance characteristics, all of those performance characteristics are sub-millisecond response time. In fact, the low sub-milliseconds, measured in 500 microseconds and below in almost every single case. I'll pause for a bit so you can look at this table and digest. Now let's switch gears and look at throughput and IOPS. And when measuring throughput and IOPS, you typically put as many threads as you possibly can for each one of the block sizes to get the most throughput you can possibly get. In this test, what we did is we threw as many threads until we got to the point where we saturated that particular test suite and got the most throughput given that block size. And whatever that block size was and that thread count that's the IOPS we got down below. So again, I've highlighted in yellow 64K block size, as it is a typical SQL Server block size. So as you can look through this, you can see the various throughputs it gets for each one of the particular block sizes based upon bare metal Windows or Windows inside of VMware. And again, Linux is there from a reference perspective. So now let's turn it over to Phil. So some pretty impressive performance all across the board. Our performance testing using DISP. It's small block size or large block size, whether it's Windows TCP, Windows RDMA, or Windows inside of VMware. Pausing a bit so you can look at those numbers before I continue on.
Today we'll be demonstrating the performance of Windows NVMe-over-Fabric devices leveraging our Pavilion NVMe-over-Fabric TCP driver. We're running Windows Server 2019 Data Center Edition. The server name happens to be Win018. And we've already got a number of NVMe-over-Fabric TCP devices discovered and configured on our host. We'll be leveraging the backup volume, which I've pre-staged a 10 gigabyte file to use against disk speed. As you can see, I've pre-staged disk speed task. This happens to be 100% read workload for a duration of 30 seconds. We're using a block size of 64K, which happens to be representative of a typical SQL Server workload. We'll be running with a thread count of 112, an I/O depth of 1. As we can see, we don't have much traffic going over our 100 gig Mellanox Connect X4 Ethernet adapter, so I'm going to go ahead and execute the job. Here you can see we're getting about 45 gigabits per second throughput. We're going to let this run for the duration of the 30-second task. So the task is finished. Let's go take a look at the results. Here we can see we're getting about 5,300 MB. It translates roughly to about 6 gigabytes per second with a great response time of about 1.3 milliseconds. Next, we're going to execute the task in 100% write workload. We're going to change -W0 to W100, representative of 100% write workload. And I don't need to run quite as many threads to achieve maximum write throughput performance. So we're going to reduce the thread count to about 36. Go ahead and execute the task. Here we can see we're getting about 27, 28 gigabits per second. We're going to go ahead and let this run for the duration of the 30-second interval. All right, so the task is completed. Let's go ahead and review the results. Again, you can see we got about 3,300 MB throughput. It translates roughly to about 3.4 gigabytes per second at an awesome latency of 681 microseconds. Finally, we're going to show you optimal latency of the solution by running the task with a single thread. So I'm changing the thread count from 36 to 1, and I'm going to go ahead and execute the task. Here we see we've got throughput to the device. I'll let this run for the 30-second iteration, and we'll review the results. All right, so that's finished. Now we can see we've achieved a 239 microsecond latency, which is really, really impressive. Thanks for your time.
Thank you for spending time today to learn a little bit about SQL Server performance as it relates to Pavilion. If you want to learn more about us, check out our other videos at www.pavilion.io, or you can reach out to us via email at info@pavilion.io, or always reach out to us at the phone. We'd love to talk to you about how Pavilion can help you solve some of your most challenging business problems and help you deliver better outcomes to your business. Thank you.